very good morning to all dignitaries, presenters, guests, participants, and delegates. I feel privileged to extend my warm welcome to all presented here for the inaugural ceremony of the International Conference in Data Science 2021. I am Seka Dalatumulla and I will be your host for today. Before we begin, it is customary to first light the oil lamp to bring in divine blessings. Before commencing any auspicious occasion, to bring in the light, today we will be lighting a virtual oil lamp today. To do the honors, I would like to call upon the Vice Chancellor of the University of Colombo, Senior Professor Chandrika N. Vijayaratne. She will be then followed by the Dean of the Faculty of Science, University of Colombo, Senior Professor Upul Sonadara. The Head of the Department of Statistics, University of Colombo, Professor Chantima Tilakaratne. The Conference Chair, Director of the Center for Data Science, Senior Lecturer of the Department of Statistics, University of Colombo, Dr. Samira Viswakula. The keynote speaker of the International Conference in Data Science, Professor of Statistics, Adjunct Director of Graduate Studies, Yale University, Professor John Emerson. The guest speaker of the International Conference in Data Science, Center for Quantitative Medicine and Program in Health Services and Systems Research, Duke National University of Singapore Medical School, Professor Bibas Chakraborty. The guest speaker of the International Conference in Data Science, Professor of Statistics and Data Science, Department of Mathematics, Rowan University, Professor Uma Shankar Thayasivam. A representative from the board of the Center for Data Science, Professor at the Department of Human Resources Management, Faculty of Management and Finance, University of Colombo, Professor Pavitra Kailasapati. A representative from the Strategic and Knowledge Partner, co-founder, owner of Creative Software, Mr. Sajid Piris. A representative from the Technical Partner, Director, Altria Consulting Private Limited, Mr. Rohita Vijayawardena. The founding director of the Center for Data Science, Senior Lecturer, Department of Statistics, University of Colombo, Dr. Rasika Jayatilaka. The workshop partner, Associate Director, Specialized Solutions, Equity Knowledge Partners, General Council Member, SLASCOM, Mr. Rohan Fernando. The mini hackathon partner, the President of the Stat Circle, University of Colombo, Ms. Saumya Karnadika. A representative from the presenters of the International Conference in Data Science, University of Colombo School of Computing, Mr. Ayesh Buddhima. A representative from the organizing committee of the International Conference in Data Science, Senior Lecturer, Department of Statistics, University of Colombo, Dr. Dilhari Artikala. Thank you. Now, ladies and gentlemen, it is time for us to formally commence the event with the national anthem of Sri Lanka. May we all now please rise for the national anthem.
Sri Lanka Mata, Upper Sri Lanka, Namo 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 Mata, Sundara Siri Harini, Surandi Ati Sobhamana Lanka.
Welcome again to the inauguration of the International Conference in Data Science 2021. The Center for Data Science, jointly with the Department of Statistics, University of Colombo, has organized the first ever Data Science Conference in Sri Lanka in order to commemorate the 5th anniversary of the Center for Data Science, the 20th anniversary of the Department of Statistics, and the 100th anniversary of the Faculty of Science, University of Colombo. This two-day virtual conference held under the theme Data Science Reshaping the Future is going to be packed with many events and activities. So stay tuned for all of this. We are very excited to note that this conference has attracted some of the world's renowned resource personnel and representatives. With such a diverse and dynamic representation here in this audience, I am sure that everyone is eagerly awaiting for this two-day learning opportunity in this enriching forum. So, to formally welcome all of you and for giving us the gift of your presence here this morning, I would like to invite the conference chair, director of the Center for Data Science, Dr. Samira Viswakula, to address the gathering.
Thank you, Seka. A very good morning, good afternoon, and good evening to you all. I'm honored to welcome you all to the International Conference in Data Science, ICDS 2021, the first ever data science conference held in Sri Lanka. This conference is organized by the Center for Data Science jointly with the Department of Statistics, Faculty of Science, University of Colombo to celebrate the 5th anniversary of the Center for Data Science, the 20th anniversary of the Department of Statistics, and as part of the centenary celebration of the Faculty of Science, University of Colombo. I would like to warmly welcome to the conference Senior Professor Chandrika Wijeratne, the Vice Chancellor of the University of Colombo, Senior Professor Upul Sonnadara, Dean of the Faculty of Science, Professor Chandima Tilakaratne, Head of the Department of Statistics. I would also like to welcome the esteemed panel of keynote and guest speakers. The keynote speaker, Professor John Emerson, Yale University, USA. The guest speakers, Professor Bibas Chakraborty, Duke NUS Medical School, Singapore, and Professor Umashanga Thayasivam, Rowan University, USA. Last but not least, I would like to welcome the following distinguished guests and attendees: Strategic and Knowledge Partner, Creative Software, and Technical Partner, Altria Consulting Private Limited, Director UCSC, Board of Management of the Center for Data Science, Registrar, Bursa, and Librarian of the University of Colombo, Heads of the Departments, Senior Assistant Registrar, Senior Assistant Bursa, Librarian of the Faculty of Science, fellow academics, distinguished guests, ladies and gentlemen, dear participants and staff of the Department of Statistics. The first day of the conference will attract academics and researchers across the areas of research in data science, from data visualization to deep learning and AI. We are confident that the 6 technical sessions planned for the day will facilitate collaborations between academia, industry, and students. The 2 main activities scheduled for the second day include 2 workshops and the final round of mini hackathon, which has attracted students and data science enthusiasts across the country. The mini hackathon has attracted 89 teams of some of the best young minds in data science, while the workshops will be conducted by some of the leading academics and industry professionals in Sri Lanka. To organize a conference of this magnitude in the midst of a pandemic is not an easy task. The organizing committee planned and executed all activities virtually. We are now rolling out the conference proceedings virtually as well. I hope you will have an educational, productive, and enjoyable time at this very special conference. Thank you.
Thank you very much, Dr. Samira, for that very sincere and warm welcome. It is with great privilege that I call upon the head of the Department of Statistics, University of Colombo, Professor Chandima Tilakaratne, to address the gathering next.
Good morning. Vice Chancellor, University of Colombo, Senior Professor Chandrika N. Wijeratne, Dean, Faculty of Science, Senior Professor Upul Sonnadara, the Registrar, Librarian, and the Bursa of the University of Colombo, Deans, Directors, and Heads of the Departments, Board of Directors of the Center for Data Science, Keynote Speaker, Professor John Emerson, Guest speakers, Professor Bibas Chakraborty and Professor Umashanga Thayasivam, representative from our industry partners, other distinguished guests, dear presenters, and participants of the conference. I consider it as honor to address the audience as the head of the Department of Statistics. International Conference in Data Science 2021 is jointly organized by the Center of Data Science and the Department of Statistics of the Faculty of Science, University of Colombo. The Department of Statistics celebrates its 20th anniversary in this month. Furthermore, in this year, Center for Data Science celebrates its 5th anniversary, while the Faculty of Science celebrates 100 years of excellence in science. This conference was organized as a commemoration for all these three events. The Department of Statistics is regarded as the frontrunner in Sri Lanka for producing not only statisticians, but also data scientists. A survey which was carried out recently revealed that nearly 75% of the graduates produced by the department during the last 5 years are employed as data scientists, data analysts, or business analysts. Nowadays, there is a high demand for data scientists produced by the Department of Statistics of the University of Colombo. A considerable number of our recently passed out graduates present their final year research studies at the technical session of this conference. This conference provides the platform for data scientists to communicate the novel concept in data science, as well as the applications of data science techniques to solve real-world problems. It also enhances the collaboration between academia and industry. Department of Statistics, in fact, maintains a very cordial relationship with the industry. This conference will create an opportunity to strengthen the link between the department and the industry. I hope this conference will open doors to new developments and enhance the research in the discipline of data science. I wish all the best for all the presenters and also wish the participant a fruitful conference. Thank you.
Thank you very much, Professor Chandima Tilakaratne, for your stimulating words. Now, I would like to call upon the Dean of the Faculty of Science, University of Colombo, Senior Professor Upul Sonadara, to address this virtual forum. Please bear with us for a few seconds until Professor Upul Sonadara joins the meeting. I apologize for the delay, and once again, I would like to invite Senior Professor Upul Sonadara to address this virtual forum.
Thank you very much, and good morning. Can you hear me?
Yes, sir, we can hear you.
Thank you. Professor Chandrika Vijayarathne, Vice Chancellor, University of Colombo. Professor Chandima Tilakaratne, Head, Department of Statistics, University of Colombo. Dr. Samira Viswakula, Conference Chair, Department of Statistics, University of Colombo. Distinguished invitees, ladies and gentlemen. It's my pleasure and privilege to address you as the Dean of the Faculty of Science, University of Colombo, at the first International Conference on Data Science, Reshaping the Future. This conference is organized by the Center for Data Science in collaboration with the Department of Statistics, especially to mark the 20th anniversary of the establishment of the Department of Statistics under the Faculty of Science, University of Colombo. As you may be aware, this year is a very special year for the Faculty of Science, since we celebrate 100 years of excellence in arts and science education at University of Colombo. The University of Colombo, with its roots going back to the establishment of University of College in 1921, played a leading role in the modern day university education in Sri Lanka. The Faculty of Science came to existence in 1942. By this time, graduating students were going overseas, and they gained research experience by working with many well-known scientists. Many of these students came back to Ceylon and joined the faculty and contributed to the development of science and technology in this very institute. By 1950s, University of Ceylon was one of the leading academic entities in the Commonwealth. From 1960s to today, academics of the Faculty of Science contributed immensely to the higher education and science education in the country. Due to the timely development work carried out by our faculty and staff, we have more than 2,000 undergraduates pursuing 30 honors degree programs in the faculty, while our postgraduate student population enrolled in various master's and doctoral degrees, it has now grown to over 400. There's a high demand for A-level science and mathematics students to enter the Faculty of Science, University of Colombo, to pursue degrees in science, and students with high research scores are given this opportunity. Other than applied mathematics, which is a compulsory subject offered to 300 students enter in the Faculty of Science under physical science, 80% of the students selected to do statistics as one of their subjects, so making it one of the most popular subjects in the faculty, perhaps due to the available employment opportunities. At present, Department of Statistics, they offer 4-year honors degree programs focus on 2 tracks, academia and the industry. With the emerging new interdisciplinary subjects such as data science, where knowledge in mathematics and statistics are required to analyze data to produce vital information, students in the Faculty of Science are placed in a unique position to align themselves to secure employment in a broad range of application domains. I'm sure this will be further strengthened by the newly established data science in the Faculty of Science. Let me take this opportunity to thank all the presenters and their co-authors for contributing to the dissemination of their research findings and the participating at this conference. On behalf of the Faculty of Science, I extend my sincere gratitude to the organizing committee for working under difficult conditions to make this event a success. In closing, I hope that all of you will actively participate in this conference and share your valuable ideas. Thank you very much.
Thank you very much, Professor Upul Sonnadare, for your gracious address. I would now like to invite the Vice Chancellor of the University of Colombo, Senior Professor Chandrika N. Vijayarathne, to address this gathering.
Ayubowan, a very good morning, a good afternoon, and a good evening to all of you joining from many parts of the world. On behalf of the University of Colombo, I wish to thank the Dean Science, the Head of Statistics, and particularly the Conference Chair and the Director of the Data Sciences Center for making use of this very important milestone of your faculty, department, and center, despite all the problems we are facing in terms of health and safety. Warm congratulations to all the conference organizers, as well as the respected members of the Board of Management for enabling the participation of such an esteemed panel of speakers, and a warm welcome to our keynote speaker, as well as those who are giving guest lectures. I wish to thank all the participants for sharing your knowledge, as well as joining into the research discussions. And I note that there are more than 4 of our Sri Lankan university graduates and academics who have joined in, which paves the way for so much of intermingling, exchange of ideas, and also multidisciplinary research in the future. So in that sense, I must pay a special tribute to our pioneers, particularly the late Professor V.K. Samaranayake, and those who paved the way for enhancing the study and the value addition of the knowledge of mathematics, statistics, and particularly the related field of computer science. As stated by Professor Chandima Tilakaratne, a recent survey of graduate tracking showed that our students are employed to the fullest and have happy stories to share with us. And I'm sure that in the coming years, you will be able to upscale your outreach. And I'm very grateful to the industry and strategic partners for joining in on this very momentous occasion. I also noticed that the students' mini hackathon is been organized, and I congratulate the organizers for taking this on. And I would look forward to further interactions and similar activities which will take your field further forward and engage all the other components of our much loved university to get the best of the best in terms of data science. So all the very best. Have a wonderful day, 2 days of deliberations, and we look forward to hearing more from you in the years to come. Thank you.
Thank you, Professor Chandrika Wijeratne, for your uplifting words of encouragement. Well, coming up next, ladies and gentlemen, is a much awaited item on our agenda. It is now time for us to pay attention to our keynote speaker of the International Conference in Data Science 2021. To introduce the keynote speaker to our audience, I would like to invite the chair of the conference, Dr. Samira Viswakula.
Thank you, Seka. Professor J. Emerson is the Director of Graduate Studies in the Department of Statistics and Data Science at Yale University. He studied at Williams College, Oxford University, and Yale University before joining the faculty at Yale. His academic work has included Bayesian change point analysis, statistics in sports, computational statistics and graphics, and environmental science. He is the lead statistician of the Yale Environmental Performance Index, and he is working to apply similar rigor to the analysis of ESG metrics for applications in finance. He is the author or co-author of many art packages with collaborators and students. He has been a visiting faculty member at Yale NUS in Singapore. He teaches courses and workshops both virtually and in person around the world. And he gave the inaugural keynote address here at the Center for Data Science in Colombo back in 2015. He has fond memories of Colombo, Mount Lavinia, Hambantota, Galle, and the Heritage Tea Factory Hotel near Nuwara. He looks forward to returning to Sri Lanka in person as soon as possible. Now I would like to welcome Professor J to deliver the keynote address. Over to you, Professor J.
Thank you very much. So first of all, can you all hear me? Is my audio working?
Yes, sir, we can hear you.
Thank you so much. I found a photo from one of my visits to Sri Lanka, and I'm using it as my Zoom background here. I'm very pleased to be here. I should thank the conference chair, the head of the Department of Statistics, the Dean of the Faculty of Science, as well as the Vice Chancellor of the University of Colombo for their welcomes and introductions. It really is a pleasure to be here. And I was here first back in December of 2015. I'm very pleased to be invited to give the keynote address at that inauguration ceremony of the Center for Data Science. Honored to be there in person, it's important to emphasize. And I really am sorry that I can't be with you in person today. So a brief comparison of what I spoke about in 2015 versus 2021. In 2015, I included some technical examples with code, and I decided for this talk today that I would not. I'm going to give a higher level talk that I hope is accessible to everyone, and I hope at the same time that I can give you something to think about. So since 2015, a lot has gone on in the world of data science and at Yale. We actually changed our name from the Department of Statistics to the Department of Statistics and Data Science. Interest in the field has just exploded. We had an early small major with only 4 or 5 students a year, and we now have 60 to 70 students per year in the major. We offer a new certificate in data science that serves another good handful of students, students majoring in something else, but students interested in data science to complement their work. We offer a new Master of Science in Data Science, and we have about 20 graduate students a year in that program, which we strive to keep very small. And so this is quite a bit, and you might ask why so much? And frankly, it's because of student demand, industry demand, and research demand. There is demand for all of this activity, and it's terrific, but it's also a little overwhelming. And let me repeat that, we are really overwhelmed. We're trying to do many different things that we believe in, things that are important, but we need help, and it's very difficult to hire top people in the field. However, we're employed, we stay busy, and it is very exciting to be working in the field of data science right now, as I'm sure you all are aware. So we have learned some things, and I've already alluded to some of these. First of all, we really can't do it all by ourselves. We've discovered that we really do need help from other departments, and that data science should be a collaboration, not really a competition. I think we were perhaps worried originally that we needed to stake out our territory and we needed to be data science at the university. And I think that was a mistake. I think that we really should have reached out even earlier to develop collaborations. And I think we did a pretty good job. I think we could do better, and I know that we're trying to do better right now. They're very exciting times. So let me just give you a rough estimate of what I'll talk about today. I will give a very brief introduction to how I accidentally became a data scientist. I'll then provide several examples of data science from my work, and I'll give a brief conclusion with observations and perhaps a little bit of advice. So briefly, my background, which has already been partly introduced, but I'm going to go back even further to the age of 8 when our television died and my parents told us that they would not replace it. My brother and I were very disappointed. However, they very soon after that got our first computer, which was an early competitor to the IBM PC, and they got me a basic compiler with a color monitor. So instead of watching TV growing up, I actually learned to write code. And that was a terrific introduction to data science. I studied at Williams College and then Oxford, and both of those were fairly technical in nature with lots of programming in many different languages. I decided that economics was not for me, so I returned to the US and went to Yale to do my PhD in statistics, working with John Hartigan. But again, I did lots of computational things, programming in many different languages, and did early consultations for CBS network television that you could really call data science. But back then, of course, we weren't calling it data science. After that, I actually worked in the Department of Geology and Geophysics for several years doing Unix systems programming. Again, increasing my technical background, and was able to do part-time teaching in the Department of Statistics. And this really provided some of my earliest collaborations with people outside of our department and gave me some breadth of experience, getting to know people who really were doing data science, but they were doing data science from other fields. And I'll come back to that thought later. I then joined the faculty, and I've been on the faculty since, doing many different things, including advising of PhD students. I'll talk a little bit later about statistical clinics. I have been director of graduate studies pretty much forever. It's something I really do enjoy. And I love to travel, and I certainly hope that I can travel and come visit you in the coming years. I have one more slide here, and then we'll get into the meat of it. I also do private sector consulting and training, and really part of this, of course, is for my own benefit, but part of it is an opportunity to build bridges between our department and some of these companies, organizations, and government institutes, because they really do provide wonderful opportunities for our students as they enter the world as data scientists. So the core of my talk will really cover 3 different examples. Two are relatively short topics, and one is a little bit longer. And I'm going to start by talking a little bit about the statistical clinics. The main example is one from real-world data analysis, and then I'll close with some thoughts about course development and collaboration, because I think that's particularly important to note in the university setting. And as I promised, there will be no code today. So the statistical clinics are really a service that I offer with my graduate students to other students, faculty, and researchers around campus. And it meets every Friday afternoon during the semester. It's 2 hours long, and we only have 1 visitor per day by appointment. The starting point is a data set. It's that simple. A data set and some research interest. We don't do any preparation for this, and that might sound very odd, but I'll give you a little bit more detail here in a minute. It does require humility. A willingness to ask questions, to make mistakes and recover from those mistakes. And it's a little bit scary sometimes, but it's a lot of fun and a terrific learning experience for our students. So the first 5 minutes involve an introduction from the visitor, and then the visitor introduces the problem. What are they trying to learn? What do we have available in the data set? Maybe what have they done already as part of their own exploration? And then the rest of the session is really real-time, interactive data analysis. It's a 3-way conversation between, say, me as the leader, my students, of course, helping. The second party to the conversation would be our visitor or client, you might say. And then the final party to the conversation is the data set. And we, of course, humans, talk about what we're trying to learn, talk about what we know, talk about what we suspect might be true, and then we can go to the data set and explore it and see if in fact it is true, or if there's evidence that it might be true. And that distinction, of course, is subtle. We all understand it, but that even is a little bit odd for some of our visitors. So I promised to keep that brief. The main example that I have today is from a real-world data analysis project where I encourage you all to do things that have visibility. I think that's very important in academia. And the last time I gave a talk in Sri Lanka, I talked about work that I had done in the scoring system for Olympic figure skating. And it's a terrific example. I love talking about it, but I didn't want to give the same talk twice. And so instead, I thought I would turn to work that I've done over almost 20 years now on something called the Environmental Performance Index. And I have a series of slides. Some of them are general and some of them are very specific. And we'll talk a little bit about Sri Lanka. So the Environmental Performance Index is a collaborative project between researchers here at Yale University and at Columbia University. And we provide a ranking of countries based on lots of different elements of environmental performance, but divided into two main categories. I'll speak about that more in a few minutes: environmental health and ecosystem vitality. We do this every 2 years. The very first release was the Environmental Sustainability Index, and I was lucky to be on a dissertation committee of the graduate student who was one of the lead authors on that project back around 2000. It started out as the Environmental Sustainability Index, but then it morphed into the Environmental Performance Index. And that was because of preferences and an awareness of available data on the part of the researchers who were really environmental scientists, not data scientists per se. Every 2 years, we bring out a new version, and you can see the covers here look very similar. We try to keep them colorful, exciting, and we try to reach out to people outside of academia. For years, we actually released this at the World Economic Forum in Davos. Of course, the last year or two has cut down extensively on travel, but we hope to maybe rejoin that in the future. At the highest level, we have overall scores coming out of the EPI. The last release is 2020, and we're starting the new release right now. And we always summarize the top few countries and highlight the United States. That's fairly typical. And I think we have about 180 countries with sufficient data to provide rankings. We have color-coded groups of rankings here. And I think probably if you look at that map and you look at some of the shadings, I don't think there's probably big surprises there, just based on your awareness of the world and what you know about various countries in the world. But let's dig a little bit deeper. The EPI report isn't just about one overall score. At the highest level, we do have one overall score, but beneath that, there is a wealth of information. We provide scorecards on each country. We make important peer group comparisons, and I will come back to that, talking a little bit about Sri Lanka. And we also try to look at trends. We'd like to say, well, you might not be that good, but you're headed in the right direction, and we're encouraged by that trend. Or on the flip side, you were doing really well, but you're headed in the wrong direction. Both those things we think are very important. So this picture really sums up the overall index, together with the one maybe on the next page. At the very top, we do have the overall environmental performance index. Beneath that, we have the two policy objectives. That's the terminology we use to describe environmental health and ecosystem vitality, shown here maybe in the center of the circle. Inside each of those, we have issue categories. And so the next circle is really trying to describe those issue categories: air quality, for instance, sanitation and drinking water, heavy metals, waste, agriculture, air pollution, climate change, and so on. And then within each of those issue categories, we have individual, most detailed metrics or environmental indicators. And that is the organization of the EPI. You could also think about it this way. If you're teaching a class, you might have various assignments, tests, and papers that contribute to a course grade. And you as professor might be done with it at that point. When the course is done, the students take off and that's it. But you know, of course, the students are taking many courses. And so they might then have an average grade for the semester. Or over the course of their entire studies, they would have an overall GPA. And that's essentially what we're doing with the Environmental Performance Index. At the lowest level, we have individual indicators that are then aggregated up into an issue category, and those into the two policy objectives, And finally, those are averaged together into the overall EPI score. A different view on the same story, again, the two overall policy objectives, environmental health and ecosystem vitality, divided up into the issue categories. And then each of those issue categories are based on underlying indicators. We do have some indicators that are new, innovative, and are drawing on best practices by environmental scientists, not just at Yale and Columbia, but at other colleges, universities, research institutes, nonprofit organizations. We use data from the World Bank, the United Nations, and many other sources. This is just one example of that, where we've tried to do a better job studying ozone exposure over the past few iterations of the EPI. So the EPI 2020 results are all available online. One very important aspect of this that I like to emphasize is quite simply transparency. And by transparency, I mean that we are not hiding anything from you. All of the data sets that we use are available for download on our website. Everything is documented. The details of our methodology, the targets for good performance, or at the other end of the spectrum, bad performance, various transformation of variables used, everything is included there in the documentation, appendices, and available for downloads. Of course, if you don't want to download and actually work with the data, you're welcome to browse through them on the web. But by making this completely transparent, we're acknowledging that this isn't the only way to do this. It's important to acknowledge that there's nothing sacred about the way we have put the information together. Now, I might think we've done a pretty good job. I would acknowledge that each new iteration, we notice new things in the data that weren't there before, and we might adapt the methodology somewhat. We try to incorporate new variables that are best in class, high quality, preferably available as time series, so we can study trends. We're trying to do the best we can with data sets that can be available to the entire world without making use of proprietary data sets that would be hidden. Another example of what we try to do is, once again, to study trends. In the area of environmental health, this slide is showing, perhaps, trends at the world level. And so 10 years ago, the performance of the Earth as a whole, everything averaged together, would be represented by the brown points. And then the current performance in 2020 would be shown by the green points. And it looks like we actually have improvement pretty much there, other than, it's worth pointing out, the controlled solid waste variable for waste management is a new indicator, and therefore we're unable to study any trend. Ecosystem vitality is quite a bit larger. And here you have a mixture of changes. We have quite a few things that are increasing over time, and that's hopefully a good sign for our world. We do, however, have some areas where we're getting worse. For instance, all the way down at the bottom, black carbon emission and CO2 from land cover, those really look like we're heading in the wrong direction, and it's going to be a problem for the world. There's one curious thing here you might have noticed up near the top, the marine protected areas. 10 years ago, we might have been at 72.4, and now we're at 100. I looked at that actually, and I wondered if there was a mistake in our code. But I checked with researchers, and actually that's an area where we have made terrific progress in marine protected areas. And the target that is actually used to describe what a perfect score of 100 would be is such that as a world, we are exceeding that target. Now, maybe the methodology and the target needs to change to encourage continued protection of these marine protected areas. But that actually looks like a case that's a great success story. So these are all at a very high level. You might be saying, well, that's great, but why don't you tell us a little bit about Sri Lanka? So let me see if I can do that and show you how you can dive a little bit deeper into the data and make comparisons. And I think one very important comparison to make is based on region. It doesn't make sense for everyone to compare themselves to Switzerland or Norway, right? We can't all be as good at environmental performance as wealthy countries like Switzerland and Norway that have a long history of environmental protection and activism. So we have these geographic regions, and that of course is just one way to group countries. But if we do that, then we can zoom in and look at the results. This is showing a simple scatter plot on the x-axis, the environmental health scores, 0 being the worst, 100 being the best, of course, and on the y-axis, the ecosystem vitality scores. And so this is showing a world scatter plot, but with coloring based on region. But I'm hoping that everyone here is looking at that and saying that's not very helpful, and you are right. So let's move away from this to something that might be a little bit more helpful. Visually, separating these plots into separate scatter plots by region, and then highlighting a small sample of countries within the region. So these are just 4 of the regions that we saw a few slides earlier. But down here in Southern Asia, we have Sri Lanka right there. And Sri Lanka is an interesting case, actually doing very well within the region. If we skip ahead a little bit and consider the overall EPI score, and considering that as it relates to GDP per capita on the x-axis, there's also an interesting story where Sri Lanka, within the region of Southern Asia, does very well, not only in terms of economics, GDP per capita, this is logged, of course, but also does very well in terms of the overall EPI. In fact, if you took Sri Lanka and put Sri Lanka over here in sub-Saharan Africa, it would be about there, and it would be one of the leaders if it had been in sub-Saharan Africa. It would actually stack up reasonably well in Latin America, and not in the top half, but doing okay in the greater Middle East. And that's a little bit easier to see when you split the plots apart like this. If we really zoom in and focus on the real success story for Sri Lanka, the environmental health part of the picture, Sri Lanka does very well together with Maldives. Those two are way ahead of the rest of the pack in Southern Asia. A few more things here. I cut off the table because it was really too big to appear in a slide. So this is the bottom of 3 columns of the table. And we can see Sri Lanka right there, overall having a rank of 109, ahead of China, ahead of India, ahead of a lot of other countries that you would recognize, and sitting almost in first place, but a very close second place behind only Bhutan in the Southern Asia category. So what are perhaps some areas where there could be some improvement in Sri Lanka? Waste management and controlled solid waste, some things associated with fisheries, fish stock status, trawling, and possibly water resources and wastewater treatment. Those would be things that maybe would be identified as areas of improvement. However, there's some where there's real success stories. And so here you might say these are areas of leadership for Sri Lanka. Terrestrial biome protection, wetland loss is very low, that's terrific. And the emissions growth rate in methane and nitrous oxide, for example. Sri Lanka can be considered a leader there, and it really helps the scores. It's one of the reasons that Sri Lanka is doing so well within the region. And so there you have a basic summary at the highest level, and then down at a lower level for Sri Lanka compared to the region. And so I'd like to shift to the third example that I have and talk a little bit about course development and collaboration, and the importance of course development and collaboration to a budding data science department. And frankly, that includes most data science departments because they're relatively new. Although as I think about it, I think it's really a terminology issue. I really don't feel that I've been doing anything differently in the last 5 years. I've always done things that were very data-centric, computationally focused. I think it's a change of title in some ways. And that is important, I think, for academia, but it's just important to acknowledge that data science is far older than the last few years. It's really just a new use of a label to describe what many of us have been doing for a long time. So I want to talk a little bit about things that we have done here that have worked for us and might be possibilities for you to consider. And again, there's reasons behind these. You can't do everything for yourself. Someone spoke earlier about the growth in data science and the numbers of students who are taking data science. It's very difficult to teach large classes and maintain quality. And you can't do everything yourself. Furthermore, data science really is a huge field. It's not just the mathematics and the probability and the statistics and the computer science. It's those plus all the areas of application: medicine, biology, physics, astronomy, political science, psychology. Researchers from all of these fields and more are doing data science. And they are domain experts, and that domain expertise is critical to applied projects. You can't do it all, and so you need to partner with them. And I see that as an opportunity and not a competition. University resources are scarce. You will get more support from the university if you can form partnerships with other departments, bring them in, offer them a chance to be involved, and together through that partnership, you can be more productive and attract greater resources from the university and perhaps from sponsors who are interested in working with you from industry. All these constitute wonderful opportunities. So examples of this, first of all, the statistical clinics. I won't go back and talk about that again. There's two others that I'll mention briefly in this section. One is a collaborative introductory statistics course. It's very different from anything I've encountered anyplace else. And it's been a success for quite a while now. And then a new, very new certificate in data science. And the important aspect of the certificate is that it's not just us. We're benefiting from support from other departments to help make it happen. So first of all, I won't say anything about the statistical clinics that I talked about before. Collaborative introductory statistics. So introductory statistics is taught many different ways around the world. Some of them are very classical, and courses might be taught in the same way now that they were taught 50 years ago. Others have tried to introduce greater use of technology, and I think that's a wonderful opportunity. I do think that a lot of departments have started offering statistics courses just for students in their discipline. And that always bothers me a little bit. I think that seeing an introductory statistics course for business students doesn't necessarily serve them as well as having a general statistics course that establishes a foundation. I think that students might be left in the business statistics course thinking they know what they need to know and that nothing else is important. I think that the mathematics tends to be a little bit watered down, and they tend to avoid use of technology. Every discipline has its own approach, and I think that's valuable, but I don't think that that should be the only coverage of the course. And so we have an introductory statistics course that tries really to bridge the two approaches to the field. This particular course is divided into two halves. In the very first half, we have a wonderful lecturer who provides a general basic introduction to statistics, including numeric and graphical summaries, the necessary probability, covering core topics and hypothesis testing, confidence intervals, and regression, followed by a midterm exam. And that first part of the course is taught to everyone, even though, in fact, you might think of there being 6 courses here. The first half of the semester has all of the students together under the instruction of one faculty member who gives a wonderful general introduction. For the second half of the semester, those 6 courses split apart. They each have their own dedicated instructor specializing in a domain, specializing in some field where they have expertise, specializing in statistics and applications of that field, political science, medicine, and so on. And so those are much smaller. The quality of the instruction through close contact with the faculty is possible in a way that would be very difficult in a larger class. And the students are drawn into the topic because at that point, they can see examples using real data sets and using techniques customized to their area of interest. And I think those 2 aspects of the course are complementary. And I think that this has been very effective over the last few years. I guess I had a slide that actually summarized all of that. It's very late at night here, so bear with me. The first part of the term is in fact 7 weeks, and then the remaining weeks are divided into field-specific sections. But the key is that this can't just be done with faculty from data science. You can't do it. You could do some of it. Maybe someone happens to have a little expertise in medical research, but it's far more effective if you can pull in faculty from other disciplines. Have a professor from political science joining for the second half of the semester and picking up that small class of students most interested in political science. This winds up being a very effective way to collaborate, and we enjoyed the support of the university in this new initiative. I hope that you find the same is true if you do this or something like this that works in your settings. The certificate in data science. Now, it's one thing to say, well, we wish everyone would study statistics and data science, but that's not realistic. I think we also need to recognize that not every student needs to take all of our courses. Not every student needs to become an expert. So we do love our students, but it would be unrealistic to think that we can teach everyone, and furthermore, we really would be completely overwhelmed. So what we do need, though, are good students who have interests and expertise in other fields, generally with very applied interests and interests in working with real data. And we need those to come and bring us their expertise and to share their knowledge with us, and we can help them hopefully learn what they need to do to conduct their research. And it doesn't take that many courses. Just a few courses can be helpful to these students, but without distracting them too much from their course of study. It might be that 1 or 2 courses counting towards the certificate could actually be quantitative courses from within the student's primary area of study. And that, again, is the key. This is collaborative. Not all of the courses are taught by us. We need to rely on contributions from colleagues in other departments who do quantitative work and are experts in their field. And they can offer courses that are completely legitimate data science-y courses, even though they're not taught by faculty within data sciences. Finally, and probably the most important part of this, is that this certificate does provide a visible certification for students upon graduation. That's very useful as they head out on the job market and start looking for jobs as data scientists. And this benefit is not just for our students who are majors, but then for students across the university who are interested in adding data science to their course of study. So I have some takeaway points, and I went through and looked at what I talked about in 2015, and I thought that there were some good points there that I might repeat here, and there were some where I think I need to revise and add a little. So let me try to do that now. So as a data scientist, I would encourage you to be curious and willing to learn more and serve your students, your department, your university, your country, the world if you're doing broad research. Try to be visible set good examples, be technically capable. Data scientists need to be able to work with real data, even if you're developing algorithms and new techniques and methodologies. Being technically capable is very important. But one thing that I did not emphasize as much 5 years ago as I probably should have, is the importance of being willing to collaborate and accept help and expertise from other people. Because you can't do everything yourself. And I think by pulling in collaborations with faculty in other departments, you can actually work to build a stronger department to better serve your students and the university. Evolution of data science. This is what I had in 2015. I argued that evolution was not automatic or easy, and there was no one roadmap that I could guarantee was going to work. I'm happy to offer advice and relay my experiences, but you all need to find your own paths. The question is, does data science evolve from computer science? Or does it evolve from statistics or mathematics, or maybe a collaboration there? And then, because at the time there was a new institute or center, the question is, would there be a new independent institute or a new department? How would the structure exist within the university? And so I was very happy that I used the word collaboration on that slide, but I don't think I emphasized it as much as I should have at the time. And I've learned a bit since then. So this is, I think, my current version of the same slide updated for today. Collaboration is very important. It is a combination of mathematics and computer science and probability and statistics, and I'm adding in topics like data mining and machine learning now. But I'm also placing greater emphasis on the importance of partner departments, domains like psychology, sociology, political science, biology, astronomy, finance, and the importance of words like and we instead of words like or me. A little more advice. Some of this, again, is from 2015, but here I think it is still appropriate in 2021. As you do data analysis and practice data science, please don't be afraid of making mistakes. I think that it's very important to realize that, particularly as you're exploring a new data set, there will be surprises. It might be that a lot of the time, everything is exactly as you expect and perfectly clean and perfectly well organized. I find that that is often not the case. Almost every exploration I do, there's a problem, and that problem is just waiting there to be discovered. The problem is, if you don't look, you won't find it. And you might make guesses, and those guesses might turn out to be wrong, but that's okay. You looked, you tried something, and you go back to work and you try something else. Be critical of your own efforts, and don't be afraid to say that you don't know. And let's see if we can figure it out. And that is very important when you're collaborating with domain experts from other areas. Take advantage of what they can contribute to the project. Finally, professors, please do let your students see your struggles as well as your successes. I find that that really contributes to the right frame of mind that encourages students to be more and more critical of their own work and more effective as data scientists. So finally, I really am very sorry that I couldn't be with you in person today. I really did enjoy even looking through the pictures I had from prior trips when I was looking for the background behind me right there. I think that's down the coast south of Colombo in perhaps in Gaul. It was a wonderful trip. But I will never forget that in 2015, you did generously welcome me to Colombo. And in particular, you were the ones who introduced me to hoppers. So thank you for that. I will always remember that visit really with particular fondness. Thank you once again. And of course, thank you for the honor of being able to speak today. I really appreciate it, and I wish you all the best. This sounds like a wonderful conference. You have lots of great speakers that will probably give more technical talks than I just did, and that is terrific. And I wish you the best in your technical sessions and in the Data Expo. It sounds like a wonderful trip, a wonderful conference. So thank you very much, and I wish you the best.
Since we have some time to spare, Professor J. Emerson, would you be willing to answer some questions from the audience?
I would be willing to try.
Okay, thank you. So if anyone in the audience have any question that they want to ask, they can use the raise hand option on Zoom to ask it. Go ahead.
And I will also open the chat in case someone wanted to put something into chat. That's often useful.
Yes.
I also looked at your schedule. You're very busy today. I didn't see any breaks on your schedule.
We do have a break at around, I think this session is supposed to end at 11:15, 11 or something like that. We will have some time in between.
Okay, good. That's important. We have a hand up. Go ahead.
I see that we have a question from Dr. Artigala. Madam, you can unmute yourself and ask the question now.
Hi, Professor J. I'm Dilhari from the Department of Statistics.
Thank you so much. How can I help you?
I was excited about the graphs and charts that you showed on environmental index, and was happy to see where Sri Lanka was. I'm just curious. I noticed that it was only, the data was only up to 2020. I'm just curious to know, with your gut, with your instinct, where would we be after the Express Pearl disaster that recently happened? I was very curious to know where would we be in your chart.
Yeah, that's I'll tell you what, that's a terrific question for the following reason. The pandemic has completely disrupted the world economy and impacted the environment in many ways. Some being short-term impacts and some being longer-term impacts. For example, I think that the carbon emissions were greatly reduced due to decreases in travel, for example, and decreases in economic activity. And that decrease in carbon emissions would be a good thing for the environment. And that sounds wonderful, but it's temporary. Things are recovering now and are getting worse again in that respect. Another change was simply economic activity and changes to gross domestic product. And we have certain indicators that are denominated by GDP or GDP per capita. And so if we're constructing something based on a ratio, there's not only changes due to changes in the numerator that usually relate to the environmental science, but also changes in the denominator in some cases for doing normalizations. And so I'm actually very worried about this right now as we go into 2022, because I think we're going to face actually data science-y types of challenges in trying to continue to do the EPI and produce a 2022 EPI in a way that reflects the science, but also acknowledges that it's been a very disruptive 2 years. I think it's going to be a challenge to effectively compare the 2020 EPI to what we saw in, rather the 2022 EPI to what we saw in 2020. So you asked if I could make a prediction, and I think the answer is no. I have no prediction. And the difficulty is that the pandemic will impact different countries in different ways. And I think we're going to see some changes in the rankings across different countries that have more to do with inequities in the pandemic than the underlying environmental science in a way that we traditionally think of those. So I think that's all I could say on that. I wish I could give you a guess, but I wouldn't want to do that.
Thank you, Madam, for the question. And thank you, Professor, for that very clear clarification. So I think that we have 2 more questions in the chat.
I will reopen the chat. Thank you right there. The COVID-19 pandemic has led to a succession of problems. Absolutely. would the international network of data-driven sharing of experiences through your experts be able to support governments and policymakers with a more pragmatic approach is so dynamic and unfolding of problems? I would say that the methods that we use to make sense of environmental performance could be generally useful. I don't think that I can claim that I or my team at Yale or Columbia and our work specifically on environmental performance is apt to help give the insights that you allude to. But I think that the methods that we used in our project could be very effective in other areas where there's domain experts and different sorts of data sets that relate to different facets of the pandemic. I think that's as good as I could do on that first question. The second one, a key takeaway, being humble, that's my favorite. It serves me well. Be humble and collaborate with others across disciplines, and be open for students to see your struggles, both of which we in Sri Lanka and most of Asia are really bad at. Well, we work in silos and play the role of experts. So you're making an observation that you are in a position to make, and that's critical. I work with people around the world, and I generally find that almost any place I go, there are people who are humble and who are willing to collaborate with others. But often they are in settings that might make it very difficult to do that. And so all we can do is work together and discuss things that we think are important and discuss things that we value, and recognize that sometimes improvements will be very, very slow to come by. And that can be frustrating at times, but if we work together and we communicate and try to collaborate and share experiences across institutions that can be very different, I think that's probably the best we'll be able to do. We have perhaps one other hand up from Rohan Fernando.
Yes. Mr. Rohan Fernando, you can ask the question.
Hi, Professor Jay. Thanks. It was really insightful and interesting. So I was just thinking about the, going beyond this and thinking about ESG and trying to get your view on ESGs, because right now ESG investments are quite interesting, and a lot of people are talking about it. And I think one of the key challenges that we saw was the data, because especially you can get data for scope 1 when it's come to SDG 7 and 13, but 2 and 3, it's quite hard to find. And a lot of the data comes as very unstructured text documents. And the scope 3, it's quite challenging. So just like to get your direction and view on, how to go about such things, and do we have enough data? And a lot of networking gonna happen, because you need to connect with the supply chains and then consumers at scope 3 as well. So I'd like to get your view on that as well.
Yeah, that's I got lucky on this question, because I spent years doing exactly this. I had a small startup company with Dan Esty, who's in environmental science here at Yale, and several other partners. And we tried to do exactly this in finance. We actually had fairly good luck on things like the scope 1 and 2 emissions, and even scope 3 often. For, let's just say 5,000 or 6,000 countries internationally. I can't claim that we have worldwide coverage, but we had pretty good coverage. We started with topics related to climate change and really the E part of ESG. And the biggest challenge we had, quite simply, was data availability. A lot of data out there would be proprietary, coming from companies like Reuters or MSCI or IRCM, which is now ISS in Germany, or Sustainalytics. You probably recognize some of these companies, but those data sets are proprietary, and each of them have their own strengths and in some cases weaknesses. The approach that we were trying to take would be to merge together all available data from different sources to do our best job at making sense of them. A lot of the data sets were very messy and disorganized and unstructured, as you mentioned. And at the most basic level, you can't imagine how much time we spent doing something as simple as simply trying to figure out how to identify a company. So you have IBM, say, huge company in the US, but there's IBM equities, there's IBM bonds, and in the finance market, there's different company identifiers. They're called ISIN codes that are used by different sources for the exact same company. And you would think it shouldn't be that difficult to say, aha, this is IBM, and here's all of the data for IBM. It just wasn't that easy. And it was made more difficult by the fact that you wanted to study 5,000, 6,000, 10,000 companies, and not just 2 or 3 or 10 or 20. And so we tried to automate the process of merging together data from all different sources and make the most sense of them that we could. But in the end, we ran into licensing problems with proprietary data. And that's what made that so different from what we did with the EPI. Everything we did with the EPI is using publicly available data sources, and we can then redistribute all of the data to you so you can do the data science maybe in a different way that suits your purpose. We couldn't do the same thing with corporate data for ESG use in finance. The companies who provide data like Sustainalytics and MSCI were very protective and unwilling to give licenses that would have allowed us to do what we wanted to do. So I'm not too optimistic there. I think it's a wonderful opportunity if someone can do it, but we spent about 3 years trying to do it, and in the end we gave up, which is sad. I really believe in what we were trying to do, and I'm sorry that we couldn't succeed, and I'm sorry that I don't have a better story to tell. It's hard. It's very hard. It's a terrific topic, though, and I wish you the best if you are working in that area.
Thank you very much, Professor, for all the clear clarifications. Shall we move on then, everyone? Okay. I'm sure that you all agree with me when I say that it was a very knowledge-filled and insightful keynote speech. Just the sheer evolution of data science from 2015 to 2021, as Professor mentioned, is amazing to witness in so many examples around the world. And I'm sure that just like me, the audience gained plenty to take away home. So thank you very much, Professor J. Emerson, for your knowledgeable address.
Thank you so much.
Next, we have another highly anticipated segment of this virtual conference. It is now time for us to listen to the first guest speech of the International Conference in Data Science 2021. To introduce the first guest speaker to the audience, I would like to invite Senior Lecturer of the Department of Statistics, University of Colombo, Dr. Rushan Abegunawardana.
Thank you, Sekha. It is my great pleasure to introduce Associate Professor Bimbas Chakraborty to all of you at the ICDS 2021. Associate Professor Bimbas Chakraborty is a tenured professor of the Center for Quantitative Medicine at Duke NUS Medical School, and Associate Professor at the Department of Statistics and Applied Probability, National University of Singapore, and Adjunct Associate Professor at the Department of Biostatistics and Bioinformatics, Duke University, United States. Previously, Associate Professor Bimbas served as a director of the Center for Quantitative Medicine and as the founding co-director of the PhD program in quantitative biology and medicine at Duke NUS. Associate Professor Bimhas completed his bachelor's and master's degree respectively from the University of Calcutta and the Indian Statistical Institute in Calcutta, India. Subsequently, he completed his PhD in statistics from University of Michigan, United States, under the supervision of Professor Suzanne Murphy in 2009. He then worked as an assistant professor of biostatistics at the Mailman School of Public Health, Columbia University, United States, prior to his move to Singapore. He is the Calderon Research Prizes for junior faculty from Columbia University, Mailman School of Public Health in 2011, and the Young Researcher Award from the International Indian Statistics Association in 2017. He has served as a principal investigator of research grant funded by the Ministry of Education, Singapore, as well as the National Institute of Health, USA, in addition to being a co-investigator on numerous grants from various funding agencies. Over the years, he has also served as a scientific reviewer for several funding agencies, including the National Medical Research Council in Singapore, the National Institute of Health, the Patient-Centered Outcome Research Institute in the United States, the Netherlands Organization for Scientific Research, and the French National Alliance for Life and Health Sciences. Now, I would like to invite Associate Professor Bimbas to deliver his speech. My dear friends, please welcome Associate Professor Bimbas Chakraborty.
Let me just first share my screen. Okay, can you see my screen?
Yes, so we can see your screen.
Okay, great. Okay, so thank you for the kind invitation and also for the kind introduction. This is a great opportunity to speak to such an interesting and very curious audience of students, as well as our distinguished speakers and guests. And so, with due respect to the Vice Chancellor, the Dean of Science, the Head of Statistics, Director of Center of Data Science, and other guest speakers, I would like to talk about this topic on data science in mobile health, which I think is a timely topic. This is based on joint works with several people. Some of them are from my own lab, some of my own students and postdocs, as well as some of the external speakers, external collaborators that are listed here. So what is mobile health? Mobile health, or sometimes referred to as mHealth, this is practice of health and healthcare supported by mobile or other digital devices. And the word digital health is also quite common as an alternative. So as this picture shows, mobile phones are everywhere, right? With that kind of penetration in the entire population, mobile and digital interventions has a huge appeal, and it can potentially reduce the traditional health disparity across different parts of the population. And thus it's very useful and attractive from a global health perspective. However, I will move to more technical aspects of some of the mobile health studies that I have been involved with and associated statistical/data science issues, rather than talking about the more general aspect of its appeal in the global context. So in particular, I will be introducing a novel trial design called micro-randomized trial, sometimes called MRT, that is useful in this domain of mobile health. And this is somewhat different from the traditional randomized control trial that most of you may be already familiar with. And I'll talk about various issues related to such designs. How do you learn from data from those kind of studies? And of course, I will walk you through real examples, real data. Okay. So here is an app, mobile app. Name is Diamante. Diamante stands for Diabetes and Mental Health Adaptive Notification Tracking and Evaluation. So there are many health apps these days that helps you keep track of or manage your health condition. And this is one of those apps. Interestingly, there is also a study with the same name, Diamante. This is led by investigators at the University of California, Berkeley's Digital Health Equity and Access Lab. And this study has an overarching goal to develop, implement, and evaluate an adaptive learning clinic integrated mobile intervention, particularly targeting to promote physical activity among low-income ethnic minority patients who are suffering from both diabetes and depression together. And this is in the San Francisco Health Network. So if we segregate the goals of this study, it sends contextually tailored, contextually relevant text messages, SMS, to the patients to manage their condition, to motivate them, to prompt them to do more exercise, more walking. And these interventions, the messages are multifactorial intervention. They have different components. Another aspect of the study is to learn to send better messages as we go, as the study goes, by continuously learning from the data, adaptively learning from the data. So the study at the broad level, it's a 3-group randomized control trial with inbuilt micro-randomization. And I will come to that in a minute about the micro-randomization part. So at the macro level, there are 3 groups. First is a static messaging group. This group of patients, they receive daily intervention messages according to a fixed factorial design. The statistics students in the audience, I'm hoping that already have heard of factorial designs. If you have multiple factors of treatment, you can combine them together, you can allocate them together simultaneously. And this is an old topic in statistics. Then the next group is an adaptive messaging group. So they also get the intervention messages, but the messages are not the same throughout the study period. Here, there is an inbuilt learner, which learns as more and more data comes along the way and tries to send better messages based on whatever it learns. And the learning is driven by a class of methodology called reinforcement learning from the AI literature. And then the third group is a control group who don't receive daily intervention messages. There is only just a weekly message about, mood and steps. So that's basically the data structure. Here's an schematic of the study design again. Again, on the left box, you see the A, B, C, the 3 groups. And on the right side, it just shows the flow of things. So you first observe their time varying context, which day of the study, what day of week, whether it's a weekday or weekend, how much you worked previous day, what message did you get yesterday, all these data, time varying covariates, those are collected and made available to the system. And then, there are multiple factors of treatments that are given which are basically different kinds of messages. I'll elaborate more in the next few slides. But the point is, those messages are given every day, and then at the end of the day, their physical activity improvement is collected, computed, how much steps they walk. And this goes on for 6 months. First factor is the motivational messages factor. And it has 4 levels or 4 categories. Of course, there's a no message category, but then there are other messages appealing to self-belief aspect of your motivation. Some messages talk about the actual concrete benefits of walking. And the last one is about opportunity, about specifically telling that, how you can incorporate your exercise into your day. And this has to be done every day. Otherwise, people forget or people become lazy. So these are the aspects of, tapping on people's motivation or promoting people's motivation. And there are some example messages. I'm not going to read myself, but you can take a look at this, some of the examples. There are many more examples. There are, box of messages that we have. And preliminary evaluation of these messages were performed on the Amazon Mechanical Turk crowdsourcing platform prior to the main study. So this has a background. It doesn't fall from the sky. There has been prior work, more qualitative kind of work, evaluation, feedback to prepare this message bank. And this is what the psychologists in the team, they did. The second factor is feedback messages. Likewise, here we have 5 different levels or categories of messages. Basically, it tells you whether or not you reached your goal yesterday, how many steps actually walked, whether you walked more or less than your target. Sometimes you add a positive or negative message in addition to the step count. So different ways of framing the message, framing the feedback about your performance. Again, that was all tested out before. And then the final factor is the time frame, which time during the day you are delivering the message, whether that has an impact. That is also something that the study team wanted to investigate. Then there's this contextual variables or covariates. In statistics, we call it covariates all along, but sometimes in the data science world, in this kind of data science problems, these adaptive learning problems, we call it contextual variables. So there are all these baseline information plus the time varying variables like which day of the study, how long you have been in the study, or which day of the week, etc. And then the primary outcome is the number of steps walked in the next 24 hours. This is collected passively via the phone's pedometer. So the study design that we considered is a micro-randomized trial I mentioned earlier. These designs are cutting-edge trials that are suitable to take care of this sort of time-varying sequential interventions. And because these are multifactorial intervention, there is this motivation message, there is feedback message, time, etc. So you can think of this as an extension of full factorial designs in a sequential setting. And at each decision stage, in this case, every day, people are randomized between possible options, and each person may be randomized at hundreds of stages, right, in general. And in the study itself, this is a 6-month study. So the actions or treatments or interventions, specifically in our case, the messages, they are intended to have a proximal effect. We don't expect that people will sustain an impact of the message 2 days later. So micro-randomization helps to generate data to assess causal effect of the proximal impact, proximal causal effect. And from a study design point of view, the things that we look at is, the questions that we wonder about is how to study the power and sample size requirement for these kind of studies, particularly with more than 2 levels. And so that's with the basic MRT. But then we also want to know how to best adaptively learn, sort of learning online about more effective messages while in the trial. As the trial goes on, as we accumulate more data about people's performance, people's response to the messages, how can we use that information to send better messages to the other participants beyond that initial group. So here is the data structure formally. It's a little bit more than standard longitudinal data. There are T stages, and the trajectory of data for each individual is a collection of X, A, and Y, 3 kinds of variable, where X is the context or pre-treatment variables, A is the treatment or intervention or action, and Y is the proximal outcome, the steps in our case. And A could be a vector for multifactorial interventions, as in our case, and XT can also be quite high dimensional. So the outcome model for analysis of this kind of data, what is the basic principles that we follow in such data? So we have to keep in mind that the intervention effect is time varying. It's because, for example, with digital kind of interventions, initially we are very excited, and people in general are quite excited with a new intervention, joining a new program, etc. But then initially, for the first few days, they might even struggle to keep track of, or there's a change in their lifestyle, or navigating the technical aspect. So there might be a little bit learning curve initially. Then people are still excited after a few days, and now they're getting it, they can navigate it. So then there is a stable, good period. But then after a while, like all things in life, things lose a little bit of appeal. So people get too habituated and do not really respond. They learn to ignore text messages, right? So that habituation impact and the effect can come down. So there could be a quadratic kind of a trend. This is the time varying effect of treatment. So you have to incorporate that in your model. So even though we can, at the very basic level, we can think of a regression model, the key point here is the regression coefficients will be time varying. It's all indexed by T. So that's the message I want to give you. And then from a power or sample size point of view, if you want to design your study properly, adequately powered, you have to specify what kind of hypothesis testing you're going to do. And for that matter, in this context, it might make sense to consider an ANOVA type global null hypothesis of no treatment effect whatsoever. So you can have this null hypothesis beta 1 T through beta M T, all of them being 0 for all T. And you can, depending on your situation, depending on your specific problem at hand, this is where the domain knowledge will come in. You can and you should specify a suitable alternative hypothesis that you will be using for testing. And in the context of habituation phenomena that I was just talking about a little bit earlier, that initially there might be a learning curve, then a stable period, and then it will go down, the impact can go down. So you can think of those betas, you can postulate the betas to be a quadratic function of time. As I have written here in the equation, beta M0 plus beta M1T plus beta M2T square. Right, so there are other possibilities, of course. This is just one example, how you may want to specify your alternative hypothesis about your treatment effect, intervention effect. Okay, and then analysis involves dealing with longitudinal data, dealing with all these complexities of how you specify the effects, etc., etc. Long story short, we would need to use something like a generalized estimating equation, or GEE, for those of you who are familiar with longitudinal data analysis. So you can use that technique, some extension of that technique, to estimate the effects of the parameters. And for the testing purpose, in order to test that null hypothesis, you would end up, if you follow the technology of all these estimating equations, etc., you will end up with the fact that in large samples, the test statistic will follow a non-central chi-square distribution, and you can use that to do your test, which means you are in a position to study power and related aspects. So I just want to show you some sample size calculation necessary for achieving 80% power to test that global null hypothesis. And here I'm considering m equal to 4, m here meaning how many message categories. And you can vary, of course, all these things will impact how your power and sample size will pan out. But here is some illustration. Some of the input parameters are as usual. Here you have to specify how many decision points, t. The effect size, there are different components. So in a standard randomized trial, you just give an overall effect size. But here we talk about initial standardized effect, average standardized effect, and day of the maximum effect, as there is this quadratic kind of trend of the effect that I mentioned earlier. And of course, you have to specify your desired power and level of significance. And then based on that, the numbers are here. So the first, so the first two, second and third columns correspond to the power, correspond to the sample size corresponding to two different standardized effects. And the last two columns are the corresponding Monte Carlo powers. So one thing to note here is that even for reasonably small length of studies, relatively small values of t, even then the sample sizes are quite manageable. This is a big plus compared to traditional randomized trials, because here you have the option to pull across this longitudinal data. You are observing a small group of people maybe, but then you are getting repeated observations from them, and you are pulling information to gain that kind of efficiency, which means it is not so hard to conduct this kind of studies. It's a lot more affordable to do these kind of studies in a particular population. So for example, if someone has done in another country and you want to replicate to your country, this is quite doable and without a lot of extra hassle, or not very expensive, so to speak. Because this expense is a thing that that makes conducting randomized trials difficult, and people have to often rely on observational studies. But then observational studies often come with well-known problems of selection bias and confounding and so on. So anyway, I think this is the moral of the story, that it's possible to do it with a relatively small sample size to conduct such studies. Okay, I'll now switch gear to talk a little bit about adaptive learning that can be done within this MRT setting. And this is what we also have done within our Motivating Diamante study. Remember, we had three main arms or groups. One is the control, one is the basic MRT, and then the other one is this adaptive learning kind of MRT, where methodologies like reinforcement learning has been implemented. And what is reinforcement learning, in case you are not familiar? This is actually a technology coming from the AI field. And it's also machine learning, but it's a different kind of machine learning, not the supervised and unsupervised learning. This is something different, where you learn by interacting with an environment. And this technologies has been used in classical settings like robotics and automated flights and games, etc., etc. Specifically in our context, we feel that short horizon reinforcement learning algorithms like contextual multi-armed bandits, or MAB algorithms, are quite suitable. And these algorithms have been used in recent years, for example, in promoting online ads, online advertisements by various websites, Facebook, Google, Yahoo, etc., etc., Netflix. So because when you go to these websites, we feel like, they know what we are looking for. How do they know? So they know based on our past behavior of, web experience. And based on that, they put the right kind of ads that we are looking for. So that same idea can be useful in our mobile health setting, where we have sent certain kind of messages and we have noticed their behavior, how they are responding to certain kind of interventions. So based on that, we can tailor what kind of messages would work or appeal better to them, right? So the same kind of ideas, same algorithms. And in particular, we focus on an algorithm, and in the study we have implemented that is linear Thompson sampling, operationalized via a Bayesian regression. And this is grounded in an old statistical paper back in 1933 by Thompson. But in the recent years, with the emergence of data science, and particularly with these online advertisements and recommender systems, all these things, with the explosion of technology, these methodologies have also gained traction and gained popularity. And this Thompson sampling is a very popular method now in computer science, data science. Oops. Okay. So I'll be very briefly sharing what is a simple operationalization of linear Thompson sampling might be, and particularly what we have worked on in our study setting. So we assume a Gaussian reward model or outcome model. So basically the y given x, a, and the parameter beta. It follows a normal distribution with mean f transpose beta and variance sigma square, where f is a known feature vector, which is constructed based on both x and a. It can have their main effects and interactions, and possibly other nonlinear terms using splines, etc. And we also assume a Gaussian prior for the beta. More generally, one can use Gaussian inverse gamma priors for its, if you also consider prior for the sigma square parameter. And you can then compute the posterior distribution of the beta given all the data till that stage, t, which also turns out to be Gaussian because of the conjugacy properties. And the parameters of that posterior distribution can be computed, because essentially there is a regression going on. So the parameters of the posterior distribution can be computed via least squares or Ridge or Lasso kind of regression, whatever is relevant in a certain setting. And so specifically the TS, Thompson sampling algorithm, involves the following step at any given state, which means at any day as we go along in our study, we observe the XT, all the time varying covariates, all the baseline and time varying covariates that we have. And we also have collection of previous data from previous stages. Based on that, we have to draw a sample from the posterior distribution, call it beta tilde, and it's not just the posterior mean. This is an important point. It's not just posterior mean. It's actually a draw from the posterior distribution, and this is in order to encourage exploration, not so much exploitation of the information. You still keep learning, not just get fixated at the mean. And then you choose the optimal action, in our case, optimal message, based on this maximization of the posterior mean of the predicted outcome. Choose that action, execute that action, meaning send that message, and observe the next stage's outcome and the context, how people respond to that intervention. So in our case, in the Diamante study, the model does that every day, or rather every night. After the day's data are collected, every night it runs in the server, and next day it knows what messages to send. Okay, so that's that. And we don't yet have the final data from that study, but we have a pilot version of it. Here we don't have a control group, but we only have a standard micro-randomized trial arm and another arm with the Thompson sampling. The primary outcome is again daily steps, but it has a shorter duration, only 45 days of intervention. And this is not on the clinical population of diabetes and depression patients. These are only undergraduate and graduate students at the UC Berkeley campus, about 100 of them. And it applies all these methodologies that I have already talked about. So some data. These are the distributions of the step count and changes in step. We see, and this is something that we anticipated earlier, and accordingly we adjusted, but this actually reinforces the understanding that step count would be a skewed variable. So normality might not be most suitable, whereas if you work with the steps change from the previous day, that would be a more symmetric variable to work with. Normality assumptions will be reasonable. And these are the average step counts over days as study progresses, how things happen. So as we see on the left panel, the average step counts slowly decreases. So you might say this is an habituation. This is a habituation effect. People are losing interest or not following. However, when we look at the steps change, it still seems, average around 0 with large variations, of course. Finally, we have analyzed the data, pilot data with GEE. And so the first analysis we conducted is effect of sending any message, right? Does it at all help if we send messages, reminders, motivations? Does it really help? And it turns out that it does. We see a significant effect of sending message, but also we see a negative effect of the interaction between message and the day of study, right? So this is again the habituation. After a while, as study progresses, the effect diminishes. The next analysis is separately looking at motivational and feedback messages. We see that the motivational messages are actually statistically significant, but feedback messages are not. And then this one is a bit more granular analysis. It looks at the different categories, and we see that certain categories of motivation and feedback are significant or close to significance, others are not. And finally, this one, we look at a comparison between uniform random group, the micro-randomized group versus the Thompson sampling group, and there is no significant difference between them. Although, in fact, to a little bit surprise, Thompson sampling looks slightly in the worst direction, even though not significant. Okay, so comments about ongoing and future work. Of course, the data collection here is not perfect. It can be improved, particularly if we can introduce a wearable device like a Fitbit, etc., instead of relying on a phone pedometer, because people are not always carrying their phone. So some missing data will be there. People's steps will be missed. Model selection, variable selection in Thompson sampling is critical, and just what we saw earlier, that Thompson sampling in the pilot data was not working very well. And one potential reason is that the model that we assumed, the priors and the reward model, whatever we assumed, is not probably optimal. So this is something that there's an enormous opportunity to learn. And along those lines, you have to do a better job at modeling the habituation effect that I mentioned, and how to handle skewed large count data within the Thompson sampling framework in a theoretically solid way. That is also something we viewed as an important future work, because the traditional theoretical work, theoretical statistical kind of work, in terms of probability bounds of these different algorithms, etc., almost all of them are on normality assumptions. what if the data is not normal? We are not so sure yet, and there is not much out there in the theoretical literature also. So some take-home messages. You may forget everything else, but just a few things to keep in mind are these micro-randomized trials that I've just talked about are newer kind of trials in the mobile digital health space. They're very relevant for behavioral or lifestyle interventions. And in a way, you might say that these are old wine in a new bottle, because these are extensions of age-old factorial designs in a sequential decision-making context. Analysis involves longitudinal data analysis like GEE, and you can incorporate these adaptive elements of learning within the micro-randomized framework by Thompson sampling or other reinforcement learning algorithms. So this is an integration of classical statistical ideas with reinforcement learning, which is coming from the AI or more broadly from computer science. So in my view, that's data science, with an understanding also of the underlying domain of psychology and health behavior, etc. And finally, I want to also emphasize the fact that these kind of interventions are relatively cheap and can penetrate across a large part of the population, can help reduce health disparity and appealing from a global health perspective. Okay, here are some of the references. Again, these are all in the medical or interdisciplinary kind of journals, but application of statistical or machine learning ideas in this particular domain of health behavior change. Okay, with that, thank you very much.
I think we have enough time for one question from the audience. Would Professor be willing to answer a question from the audience?
Sure. Happy to.
Okay, go ahead. You can ask a question. Are there any questions? If so, you can use the raise hand option on Zoom. It seems like that we don't have any questions. Okay. So I would like to remind everyone that you will be able to catch the live stream of this conference on YouTube, Facebook as well. So stay tuned. Thank you very much, Professor Bibas Chakraborty, for that very insightful speech. And you certainly gave the audience a very thorough understanding about how useful data science and statistics is for different applications in mobile health. It was amazing to learn how the micro-randomized trial can be used for developing just-in-time adaptive interventions, such as motivational messages to exercise more. So thank you very much, Professor.
Thank you.
Next, we have another special segment of this conference, and that is the second guest speech of the International Conference in Data Science 2021. To introduce our second guest speaker to the audience, I would like to invite Senior Lecturer of the Department of Statistics, University of Colombo, Dr. Dilshani Tissera.
Thank you, Seka. It is with great privilege that I introduce the second guest speaker of this international conference, Professor Umashanga Thayasivan. He is a professor in statistics and data science at the Rowan University, New Jersey. Professor Thayasivan earned his doctoral degree for his research work on mixture distribution at the University of Georgia. He is also an alumnus of the University of Colombo, Sri Lanka, with a Bachelor of Science in Statistics. His many research interests span the topic mixture distribution, robust estimation, high-dimensional data analysis, statistical data mining, and biomarker discovery. Professor Thayasivan is to be appointed as the chair of the Department of Mathematics, Rowan University from the 1st of July 2021. He was also awarded the Teaching Wall of Fame Award for his excellence in teaching in 2018. Professor Thayasivam has an extensive experience with collaborating scientist engineers. He has several journal publications and numerous conference presentations. He has been principal investigator for several internal and external grants and collaboration, including the recent data mining project with Bristol Myers Squibb Pharmaceutical Company. This was just a glimpse at Professor Thayasivam's distinguished career in statistics and data science. Today, he has joined with us to share his wisdom on the topic, Future of Data Science, Quantum Computing. Ladies and gentlemen, please welcome Professor Thayasivam to address this virtual forum.
Okay. Good afternoon, good evening, good night, almost 1 a.m. here. I just want to make sure that I can share it. Is that loading for you all? Can you all see my screen or not?
Yes, so we can see the screen.
Okay, good. Okay, so first of all, it's my pleasure to be here and thank you for the invitation. And this is a special one for me because, I'm, as Dilshani shared, I'm an alumni of this school. So first of all, I would like to, acknowledge the Vice Chancellor and the Dean of the Faculty of Science and Head of the Statistics Department, as well as the distinguished speakers, Professor Emerson and Professor Chakrabarti. Also, all other, distinguished guests joined in the event. It's my privilege to be here, and also I would like to thank the organizing committee of this conference event to just give me this opportunity to share my knowledge. As like Professor Emerson, I'm going to share something more like a high-level talk about the future of data science. So I'm not directly, translating my research area. This is more like an area I'm just become fond of, and then just start, reading and working on it. But I thought this is going to be one of the area which definitely everybody should know of. So that's the reason I'm just going to share this. Okay, so as an outline of my talk, I'm going to give some introduction overall, and then I will give the motivation, and then I will talk about what is quantum computing, and then I will also talk about the application in data science, and then I will give some concluding remarks. And depending on the times, if time permits, I will try to share few of my recent projects. So Dilshani already gave me a nice introduction. Thanks for that. But I just wanted to share about me. I'm just did bachelor's in this institute 20 years ago. So I graduated 20 years ago, and then we are celebrating the 20th anniversary of the statistics department. So as you'll imagine, we are one of the first batch in this sort of the new setup as a separate department. So start from there, and I just did my master's and PhD in University of Georgia. Then I joined the Rowan University 2009 and became the professor last year. And then as starting from July 1st, I'm going to become the chair of the department. So that's the background, and it's a very pleasure and privilege to speak here because I know in the audience, my teachers are there and my friends are there, like my collaborator students are there, and my students are also there. So it's a very privilege to be here. The picture here is a new building, right? I know you guys now just recently have new building, so I couldn't find the old building picture, just put it there. Okay, so as a motivation, let's see. As we advance as species, there are a lot of things, right, that once seems to be impossible a century ago are really evolving. Right now, we create more than 2.5 quantile, like quantile mean 10 to the power 18 data bytes of data. And we expect this to grow about 3.5 quantum by 2025, especially with the 5G and then the Internet of Things. I don't know how many of you all know the first electronic calculator is built in 1960s, about 60 years ago. Now, within these 60 years, you can imagine how things just evolve. So classical computing even become more exponentially faster and capable of handling multitask. However, that doesn't mean everything we can handle is already there, right? So it is envisioned that the quantum computing will accelerate us in the future of impacting data science. So we are in the data science era. 21st century is a data science era. However, right, there is also a talk, like it's there forever, but recently it's just popping up. This quantum computing power and the speed is going to help us or hurt us, right, to handle the big data challenges. So that's what I'm going to talk about, sharing some of these information. So the quantum computing is not something new. The scientists, using for the past 120 years, it's just coming from this quantum mechanics, right? It's one of the successful stories in the modern science. Without that, we wouldn't have, the marvels of atomic clocks, computers, lasers, and the GPS, the global positioning systems, and the MRI, and many other. So what is quantum computing? I'm not going to go in a technical way, but I'm just going to give an overview of just what it is and what it differs from the classical computing what we have, so that you understand better when we connect to the data science. The fundamental of component of this new technology is what they call the qubit. It's a quantum version of the classical bit. As you all know, the computers we use in a classical bit has values 0s or 1. And joining these bits, we just create this computer representation information such as letters, numbers, and so on and so forth. The quantum bits, by contrast, can have a value of 0 or 1. At the same time, this quantum concept called superposition, in which an object can exist in 2 or more states at once. This paradox is known as Schaeffer's cat, in which a fictional cat is simultaneously alive and dead. So it's sort of a, sometimes it's not easy to grab, but the concept-wise, as you all know, it's not just a regular classical bit, it just goes beyond. A quantum bit can be in the same setup in 2 different ways. So the quantum computers can consider a lot more information. They can gather a lot more information at once, and it can increase the calculation power also exponentially. So some of the vocabulary, it might be slightly technical, just this slide, but I just want to throw the jargon because you need to know, like whenever if you start reading in the future, these words are going to come across. So I just want to give a brief overview. So the qubits, it's not bits. We are do calculation with quantum bits rather than the digital bits. That's the first thing you need to know about the quantum computing. And superposition means objects can be in more than one state at the same time. And entanglement, when qubits are entangled, they form a connection to each other that survives no matter what the distance are. And this the notion of quantum computing is a difficult task. I become just fond of this. In 2018, I went to RMIT University for as part of my sabbatical, and during that time I heard about this news about silicon microchips, the quantum coding of silicon microchips developed by the RMIT University, which is sort of one of the fundamental for the quantum world to just in the modern area. Now, just to give a background, as you see from this image, the classical computing, you have just 0s and 1s, whereas the quantum computing, you have, you can see the superposition you could be anywhere at the same time, like which can be stored anywhere as a 0 and 1 at the same time. Now, just let's say 300 qubits. A smartphone, what we have currently in your pocket, has more than 1 billion bits, not qubits, just the bits easily. So 300 qubits is not a big one number. However, if you consider the number of combinations that 300 qubits can just bring you, is going to be 2 and then followed by 90 zeros. So as you imagine, that's the main advantage of qubits, because it's going to produce so many combinations of it. It's almost like the simple discrete math, you guys learn, or permutation combination you learn. If you are sitting in a table, 10 people are sitting in a table, how many ways you can arrange is 10 factorial. But as the number increases and increases, you get this larger and larger. That concept of, the overall combination just become the issue. Now let's look at a toy example. Suppose we have a set of 100 records, and we the task of computer to find the one, let's say the Gypsies album in the stack. Classically, a computer would need to examine each individual record and make a yes or no option about whether this album we are searching for based on a given set of search criteria. So you will sort of send a query, right, SQL, and the computer gives you an output. So in this case, the query is what? Does this record satisfy my set of criteria? Right. So that's what the query. And finding the record in the question could take only a few queries. It is near the top of the stack. However, you might, if you're not lucky, so you may have to just go all the way closer to the 100 queries to get that. So it's almost like, in simple statistics, we call this uniform distributional setup. So on average, you would expect locate the correct record with about 50 queries. If you have 100 queries, right, on average, half of the total number in the stack would be necessary for us to just get that importance. A quantum computer, on the other hand, right, would locate the Gypsies album much faster. This is because it has the ability to analyze all the records at once. Not quite like all the record at once, but it's slightly complicated in that sense. But you can think like that, where the so-called superposition is we are like one can in the same level at the same time. So with this property, the number of queries need to be located the Gypsies is only about 10. On the other hand, as I said earlier, it's about instead of 50, it's 10. As this number increases, so this difference is going to be, difference in huge. So that's where the exponential advantage of quantum computing is just going to come into play. As well, some of you all might, identify this. This is the image of the telephone book, right? So if you need to find out a name, a particular individual's, phone number, then the book is arranged in the order from alphabet. So you can relatively easily locate the alphabet and then try to find the number. However, suppose if you need to look at the phone to find the number, right? So suppose you have a number, right? So based on the number, you want to figure out like who that individual number belongs to. Then mathematically speaking, if there are n numbers, it's similar to what I said earlier. You need to go through about n by 2, right, pages to find out, what's that. However, that's a classical setup. But however, if you do the classic quantum based, so the Bell Lab scientists suggest, right, and then they prove that you need to only look at the square root of n. So for 100, it would become 50 and 10 in the previous example. Let's say you have 1 million records. Then for the quantum setup, you need to only look at 1,000 as opposed to, half of million, you need to look at if you are using the classical computer. So as you see the advantage of just moving into the quantum. So what is quantum advantage? And in fact, there is a terminology people use, right? If you have read the, the recent news channels, they use this term called quantum supremacy. So what is quantum supremacy? A situation in which quantum computing has allowed for something to be computed more efficiently than would be possible for a classical computer alone. So quantum computing and classical computing together is just much, much, much higher than just the classical computing. Now, how do we demonstrate conclusively that this is, more efficient? That is where we are still struggling. There is no clear-cut answer. You can sort of claim, I think this is the best form, but it's sort of sometimes comparing apples and oranges. So we cannot really compare. So that's where my focus here is to give you an idea about what are the possible pathways we can just go over and how do we incorporate the quantum computing into the data science. So if the classical computing fails to respond, at the same time, quantum computing is just achieve the goal, then we can claim the advantage of this quantum supremacy. So the first part of this quantum supremacy, whether it's achieved or not. So in 2019, the Google's quantum computer did a calculation in less than 4 minutes, and the Google claimed that it would take the world's most powerful computer at that time, like the IBM Summit is the world's powerful computer, and they claim it's going to take 10,000 years to do it, right? And so it's about almost 158 million times faster than the world's fastest supercomputer. And here is the Google CEO. You can see this is the quantum computer, it's just. So the Google proclaimed that it has achieved the quantum supremacy with its computer, the quantum computer known as Sycamore, quantum computer that can solve complex algorithms unsolvable by any computer than today. That's what their claim. Is that really true? Maybe or maybe not. IBM, which was the superpower at that time for the regular classical computer, they quickly refuted the Google's claim. So IBM said that the Google did not correctly factor into their computer summit, right? You can compute the summit, or you can configure your summit in such a way so it's going to allow us to keep up with the Google suite. And they said it's going to be only take 2.5 days as opposed to what the Google claim as 10,000 years. So they said it's going to only take 2.5 days. Even if it is 2.5 days, if you look at it, the Google's claim it's only 4 minutes. And on the other hand, even if what IBM is said 2.5 days, right, with correct configuration, it's still much different. So definitely Google has achieved something remarkable. But whether it's actually the so-called quantum supremacy or not, it depends on how you define. However, as you will see, there is definitely quantum computers is this. So the quantum advantage and quantum supremacy, these are the two terms people use interchangeably, but there is a slight difference. Quantum advantage means the quantum computer system can perform much faster than the classical computer. So in the previous example, the IBM claim it's on 2.5 days, whereas the Google's quantum computer claims it 4 seconds. So that's much faster. So you can say it's quantum advantage. On the other hand, quantum supremacy means it's accomplished by a quantum system that has computing power so great they can perform calculation, whereas none of the conventional supercomputers cannot do that. So that's where we can claim it as quantum supremacy. So this is just a background of quantum computing. Then one last thing I wanted to say before we get into data science application is there are a couple of other breakthroughs also came in recently. 6 months ago, a team of Chinese scientists claimed to have constructed a quantum computer that can perform certain computation almost 100 trillion times faster than the world's most advanced supercomputer. And they claim this new prototype can process 10 billion faster than the Google's prototype, which I showed you earlier. So that's again sort of another breakthrough. People found that quantum computing might be able to use it in the future. And the Denmark University, they develop a light-based quantum computers, which increase in the number of qubits. Because one of the challenge we wanted to do is as we need to increase the number of qubits. Currently, the maximum we have is 53. That's what from the IBM. So the Denmark University is now developing something which they claim that it can increase the number of qubits. And of course, recently IBM with University of Chicago, right, they turned the largest quantum computer into a quantum material, so they can use this to reproduce and then just go beyond that. So these are some of the amazing quantum breakthroughs happening recently. So the hope is it will bring the liberation and the freedom to the world of science, right, today. So that's a background of quantum computing in a snapshot, not technical way, but in a general sense. And then now I just wanted to show you what are some potential applications, not only these parts, but I just want to show some of them where the quantum computing for data science. So I'm going to talk about each of them. So I'm not going to just go into the slide. I'll let me each in one by one. So the most important part of applications of data science where the quantum computing might become an important role is the data privacy or cybersecurity, or even to in a big extent, you can say the cryptography. So this quantum computing, the introduction of quantum computing is going to be currently with the classical setup. We have built all the security, right? Every security we built so far is based on classical setup, the classical computing setup. So there's a belief that this quantum computing could be a threat to cybersecurity. Cybersecurity research data scientists are worried that quantum computer could break the most modern cryptography. Today's RSA encryption, right? That's the most common encryption people use, right? The reverse Chemack encryption, where they use both the private key and public key, right? As most of you might be familiar with this. That's the encryption they use for any of the most sensitive data, which is based on 2048 bit numbers. So some estimation, the expert says the quantum computers currently what we have need as large as 70 million qubits to break the encryption. So somewhat, a good thing for the time being, because the maximum we have at the time being is 53 qubit. So it's a long way to go. However, right, it may not, right, as you imagine, I show you like in the 1960s, we had the electronic calculator, now we are a week. So things can go in a much fast manner, right? So the pace of quantum research continue to accelerate. So perhaps in next 3-5 years, who knows, right? We might be able to just do it in a quick manner, and then, it can just also break it. In fact, there's an example, right? Google and the Royal Institute of Technology, Sweden, right? They did some research work and they highlighted, this came in the MIT Technology Review, that a 20 million qubit computer could break a 2048-bit number in a more 84 hours. So that means, if you spend 8 hours, you can break any sort of a encryption code, right? If you have a 20 million qubit. So things are just going. So there's a risk of the cybersecurity if we are going to use that. Now, another important aspect I wanted to just also share. Now, we all use these so-called random numbers, right? But the random numbers we are using is from the classical setup. So the random numbers we use are not really at random at all. While seemingly random numbers have been generated from classical computers, right? But it's actually based on mathematical formulas. So given enough time and capacity and a computer system, right, which really want to hack, you can unlock the pattern of these pseudo random numbers. So this become a very, very, potential problem for high security, right, including military, cryptographies and so on. On the other hand, the theoretical study says the quantum system, however, have the ability to generate the true random numbers, right? That's the fundamental principle of the randomness from the quantum physics. So that's going to be another future people are thinking, right? So if you generate the random number from this quantum computing, so even if you build a system using using the quantum system, that cyber threat might be less compared to what we currently have. Now, applications of data science, another thing is sports. So unfortunately, I'm a big fan of cricket, but I couldn't use any recent photos of Sri Lankan cricket, so I had to use the old one. I don't want to go beyond that. You understand what I mean. But as you all know, in sports, like people use the data science. Here I share different pictures. So like one of the general cricket analysis they use, or any other sports. But in US and all, they do study about individuals, right? Especially in baseball, there's a lot of data science application just about individual. When they do like every action, they just just monitor. So that's programmed. So they have just convert that into do a study info. And in fact, the picture on the corner in the right is used to be a data scientist for Indian cricket, right? With Chris Gale. So the data science plays an important role in cricket too. So, however, like maybe we may have to do a different things, fundamental things in our cricket, but that's a different story. But just the sport. So just to share how the data science could be quantum computing play a major role. The tactical analysis in sport is a challenging part, right? Especially in team sports, which require not only data accessibility, but also the ability to explore the dynamics of this data to measure them constantly changing conditions. So the quantum computing is believed to break the limitation of conventional information provision. They can enable more efficient and knowledge accelerator. Right? Especially it's going to be beneficial for the fast-paced team sports, such as soccer, football, and cricket. Right? When I say football, this is like your the American football. So it's slightly indifferent, like your soccer is what we we all use football there. Okay. So that's sort of the background. So we are not currently using quantum computing in a big scale. Quantum computing is still everywhere in a research study, right? They haven't really explored everything in application oriented, but people are just trying different aspects. So definitely this is going to have a huge role in sports, right? Just to share one quick thing, in 27 edition of the ICC Champion Trophy, they just put a bat sensor, which they place it on the top of the bat handle, they just put a sticker. So from that, right, they can just measure the power of the bat and all sort of different things. So there is already some sort of a computing, advanced computing is just going on to translate about the knowledge of what's happening. So definitely, right, in the future, it can play a huge role as well. Now, another applications of data science with quantum computing is, especially with big airports. Of course, now the things are getting much and better, like after this pandemic. So hopefully, this is going to become a huge area of research people need to use, the airline route planning, right? So you need to just plan properly just how to put the airline. So for that, right? So research have shown from some sort of a like a case studies based study, the quantum computers can solve practical problems that traditional computers cannot solve in a reasonable amount of time for the airline route planning. The quantum computer could calculate all possible routes at once using an algorithm they developed called quantum approximate optimization algorithm. So they call QAQA. According to the researchers, a simulation of 25 quantum bits would be good enough to solve an optimization problem to computer, right? To benefit of practical use for a given airport, right? That should be good enough to just handle it. Another area of research for statistics where the future could be is financial service and fraud and risk reduction, right? So the financial service institutions are exploring quantum computing to enable calculations that are not possible with traditional computing technology. So experiment could be in terms of targeting and predictions, or trading optimization and risk profile. The optimization is going to be very important part in terms of quantum computing. As you all know, now in the modern era, like with new data science, the deep learning and all, a lot of optimization involved, right? The neural network. So there is already a quantum neural network that people are developing, where this optimization can be solved in a much faster and in a computationally efficient manner. So that could be a future also for the financial institution to just make it more stable and then targeting and predicting in the right manner. And this can help to just use the risk management tool. This is just a study. They show like how much you can save the revenue and potential by benefiting from moving to quantum computing, or usage of quantum computing in the areas of feature selection and then portfolio management, credit scoring, right, and risk analysis, and furthermore the fraud detection and all. So as you'll see, right, there's a huge potential of revenue saving if you just move in that direction, because a lot of frauds and all, right, we might just in a timely manner. Another important, interesting area, right, people found is the delivery logistics. In countries like big countries like the US and UK and all, the delivery logistics is, like especially when you're ordering in Amazon or any other big vendors, they have to just deliver it through different companies. So one of the two popular companies is UPS and FedEx. So how quantum computers can just help us here for the supply chains and transform logistics? In traditionally, they believe the UPS drivers almost never turn left. So when they drive, right? So as you all know, in US, as opposed to the driving is opposite direction to Sri Lanka, right? So for decades, what the drivers, they understand, right? So you shouldn't turn left because it will take time. So they will try to just go in the different direction to just, come across, turn right and then just take all the way to that. That's how they just usually take, because that will be more idling, less idling time, right? And then the greater fuel consumption if you just do the other way around. But it's not always reliable, right? So in 2012, the UPS began using a navigation called Orient, so an on-road integrated optimization navigation. So it's sort of using a route to optimization algorithm. So now with quantum computing, Orient can just provide more mathematical justification for what drivers had already guessed, right? So they can build an efficient right turn loop. So I am in an eastern part of USA called New Jersey, where when you're driving, they call something called the jack handle. So they put a handle on the right side. So if you want to turn left, you are not going to wait in some places to just turn left in the signal. You always turn right and then stay there, and then so that will just overall the traffic flow is going to control. So things are already in build, but with the classical computing, but with quantum computing, this might even go in further, right? So you might be able to get a better optimized pathway. So this can save so-called the million gallons of emissions, right? And also will save cost each year. So quantum computing could speed up the delivery process, right? Also help to build more reliable or resilient supply chain, as opposed to the replanning and reallocation. So that's again another, especially there could be unexpected shutdowns or late shipments, right, or cancellation. So these are ways to, right, make use of quantum computing to just one further. Okay, so there are applications of healthcare. I will just go directly. In the healthcare industry, right, you could use also quantum computing, right, to just get the diagnosis system and precision medicine and price. All those different areas where healthcare is another area where the data scientist plays a major role. And the Case Western University is using the quantum computing, right, based algorithm to improve MRI scan. So that's another area of research is going on. And the pattern matching is another area where it just become an increasingly viable. So the Volkswagen car company, they are using the quantum routing mechanism. So they are trying to give all their Volkswagen, drivers, just giving the traffic condition 45 minutes in advance, right, based on what they can, predict the behavior system. This is still at, testing phase, but there is a study going on to change, using the quantum computers to just give more pattern matching. And another important area is the augmented reality, AR technology. So that's again, you have the interactive experience to generate the power. So that's another area where people use that as well. So AR, use a lot in cricket. So these are sort of the applications. So the quantum system has a potential to do all this. Another important area is self-driving cars. The car companies like Tesla and all, they use this a lot as well. So these are some of the backgrounds and applications. And as you all know, now we use this, the dashboard. So that's again, like for day in, day out, the dashboard application. When you have these quantum computing, that's going to become handy too. So sounds good, sounds great. We have this. So is that all? Still there are obstacles, right? One of the fundamental obstacles, if people are doing research, everything is good, but not that much study has done about that. How do you input data in the quantum computer? In the practical data, real data, right? So the real data right now, we have done enough study to just build this data. The pre-processing part and all is built for classical setup. But how do we do that is still, sort of. And also we talk about this as fast page and all, it's very good. However, the data information storage is still smaller for the quantum computing. So that's another important aspect of the quantum computing might play a role. Still the quantum computing, they have not used it in the user interface. We need to store it in the big places with the temperature wise, you need to froze the temperature. So there are so many things involved in the computing part. However, I think, right, 3 decades after they were first proposed, the quantum computing remained largely theoretical, but there is no doubt in my mind, it's going to be hugely impact advances at the science of growing steadily and more encouraging quantum technology will eventually deliver the computer revolution. Having said that, one thing I want you to remember is this, right? Just don't compare the current algorithms and then think, okay, quantum computing is going to be improved that. It can, but we may have to also think quantum computer based algorithm, totally new so-called algorithm, because it's like apples and oranges. Not everything what we did here might not work over there. So always remember that, right? There is a huge area of research. So for students, the last advice I wanted to do is just to make sure that IBM and a lot of other, like Google and all, they are making available to practice you some of these quantum computing powers. So you can get explored and then try to just see. And who knows, like the next 5-10 years, right? The next era become quantum computing based data science, or they call the QML, quantum machine learning, and things can go in the direction. If you just carefully use that, no doubt in my mind, right? That's what it's going to do. So I will stop right there, right? And then again, thanks for the opportunity, and then good luck with the organizers for this, conference, and then just go forward. Thank you.
Thank you, sir. I think we have enough time for one question. Would sir be willing to answer a question from the audience if there's one?
Sure, absolutely.
Does anyone have any questions for Professor Umashankar Tayasivam? It looks like that we don't have a question, but if anyone gets a question while we are moving on, you can email them to the conference email address, and then we will, okay, I see that Dr. Artigala has a question. You may ask it, madam.
Hi, Uma.
Hi,
It
miss.
was very nice to listen to a talk of this caliber. Just want to ask Uma how quantum computing could affect the individual space or freedom or individual independence when you use it, because I saw in the sports you said it can actually monitor very minute details of at individual level. How do you think will it have any adverse effect?
Absolutely. Yeah, that's unfortunately, we are in this data science era, like with using all this, computing and every other aspects. There's no way we can avoid that. So we need to just try our best to how do we just manage that. But I don't think there's a way we can avoid that. But the only thing is, at least the quantum computer is not going to come right now immediately in a user-faced manner. It's going to be more in a research-oriented in a big site. So it might not come for an individual point of view, but unfortunately, we are in that era, like there's no way we can avoid that.
Okay, thank you, Ma.
Thank you.
Thank you, Dr. Artigala, and thank you, Professor, for your clarification. Like I said, if you have more questions, you can post them on the chat or you can email them to the conference email. Okay. Thank you very much, Professor Umashanga Tayasivam, for a stimulating speech about various transformations the era of quantum computing is going to bring upon us. It was enlightening to learn about different impacts on the future of data science from quantum computing due to its potential to be the most disruptive technology of the 21st century. It was indeed a great pleasure to listen to you. Thank you very much, Professor.
Thank you very much, and best wishes.
Before we move on to the next segments of the agenda, let me introduce the sponsors of this conference, whose generosity helped immensely to make this event a success. The strategic and knowledge partner of this conference is Creative Software. Let us now take a look at a brief corporate profile video of Creative Software.
It began 20 years ago. Two people and a dream that offered a myriad of possibilities. Today, that dream has grown into reality. One that includes more than 700 highly skilled software professionals working in multiple associated companies. Launched in 1999, Creative Software is one of Sri Lanka's pioneering software development companies. Our success story is one of steady expansion and development. For 2 decades now, we have been engaged in delivering world-class software products, creating the future of enterprise software with solutions that adapt and evolve along with the world we live in. Our technology has helped people live safer, healthier, better lives, offering them recourse to the services they need the most. We have transformed businesses, simplified lives, increased benefits, and improved accessibility. Today, Creative Software work for clients around the world and across a wide variety of sectors, from construction, logistics, manufacturing and retail, to finance, healthcare, mobile workforce, telecommunications, hospitality, mining, and education. Creative Software is proud to contribute close to 3 billion Sri Lankan rupees in export revenue to the country on an annual basis. Creative Software believes in creating an environment in which its team members can flourish not just professionally but personally. with a working atmosphere that includes spaces for reflection and relaxation, flexible working hours, regular team-building activities, professional development and training programs, and a strong commitment to encouraging a healthy work-life balance. It is no surprise that many of our team members now count 10 years or more with the Creative Software family. Retaining and attracting the best is a priority for Creative Software. With this in mind, the company invests in regular university outreach programs. With a focus on molding the software professionals of tomorrow, we opened 2 R&D centers at NSBM Green University Town and another in-house with the University of Colombo School of Computing. We are committed to aligning with global trends. Our R&D Center for AI, machine learning and deep learning provides an ideal platform for the younger generation to enhance their skills. The company also carries out a range of mentoring and research programs, as well as internships, career days, and the recently launched and very popular Creative Sixes, the first inter-IT faculty cricket tournament in Sri Lanka. All of our university engagement initiatives are designed to take talented students direct to the global marketplace and postings with our eminent international clientele. At Creative Software, we look back proudly on 20 years of unprecedented growth as one of Sri Lanka's pioneers in software exports. And we look to the future with confidence in our people, our philosophy, and in the limitless potential of what we have to offer.
Without your contribution, this event would not have been a success. A big thank you to everyone at Creative Software. The technical partner of this conference is Altria Consulting Private Limited. Let's have a look at a brief corporate profile video of Altria Consulting Private Limited.
Ever made a decision which resulted in a loss and wished there was a way to see the future? Has the performance growth of your managerial tiers slowed to a crawl? What if all the data flowing around your company could be knit together into a web of meaningful information? Clearly see the outcomes of past events and allowing them to accurately predict the outcomes of actions they take. Typically, in organizations, there is a lot more useful data lying around than your managers realize. With the advent of modern data science, it's now possible to process, analyze, and generate actionable information from this data. Data analysis can boost managerial operations and leverage your organization to the next level, resulting in a fresh phase of growth. If you get in early on this relatively new phenomenon, you can be a trendsetter and dominate your industry. We, the Altria Consulting. Our mission is to enable businesses to run better and provide meaningful, actionable insights, harnessing the true power of data. Our team consists of experienced and skillful solution experts who were early adopters of big data analytics, capable of leading and augmenting client teams to implement solutions aligned to strategy, technology, and a future-proof analytics roadmap. We are specialized in delivering business analytics, consultation, and advisory, on-premise or cloud data analytics, implementation and automation of data ingestion process, organizing data repository or data lake to enhance data analytics requirement, interactive visual data analytics solutions, machine learning, AI, and prediction models development, training and workshops to empower data-driven culture. Our ecosystem consists of alliances with world-renowned giants in the field of data analytics. Tableau, Microsoft, Cloudera, Vertica, Greenplum, to name a few. Customers in different industries like telecommunications, manufacturing, retail, healthcare, banking and finance, insurance, and government. in Sri Lanka as well as overseas have placed their trust in us, and we have always delivered above and beyond their expectations. Let us set forth together on a journey to establish a data-driven culture in your organization. Altria Consulting, striving for excellence.
I would like to express our sincere gratitude to everyone at Altria Consulting Private Limited for a generous sponsorship to our event. We really appreciate it. As this inauguration ceremony brings to an end, I would like to invite the conference secretary, Mrs. Hasuni Karunaratne, to propose the vote of thanks.
Thank you, Seka. Good morning, good evening, good afternoon to you all. Vice Chancellor, University of Colombo, Senior Professor Chandrika Vijayaratne, Dean, Faculty of Science, Senior Professor Upur Sonnadara, Head, Department of Statistics, Professor Chandima Tilakaratne, Keynote Speaker, Professor John Emerson, Yale University, USA, Guest speakers, Professor Bibas Chakraborty, Duke National University of Singapore Medical School, and Professor Umashankar Thayasivam, Rowan University, USA, sponsors, Director of UCSC, Board of Management of the Center for Data Science, Registrar, Bursar, Librarian, Head of the Departments, Senior Assistant Registrar, Senior Assistant Bursar, Librarian of the Faculty of Science, fellow academics, distinguished guests, ladies and gentlemen, dear participants, and staff of the Department of Statistics. ICDS 2021 is the first ever conference held in Sri Lanka in the field of data science, and it's my privilege to deliver the vote of thanks on this special occasion on behalf of the organizing committee. Madam Vice Chancellor, Senior Professor Chandrika Vijayaratne, we express our sincere gratitude for your guidance and support in making the first ever international conference in data science a reality. We also would like to acknowledge your invaluable leadership throughout the process. Dean, Faculty of Science, Senior Professor Upur Sonnadara, Sir, we appreciate your contribution towards the success of this event. Thank you for your fullest support given us in many ways, which we highly value. Our sincere gratitude to the head of the Department of Statistics, Professor Chandima Tilakaratne, for your commitment, immense support and efforts towards making this event a success. Words are not enough to express our gratitude to your madam for your constant guidance. I extend our heartfelt appreciation to the keynote speaker, Professor John Emerson, and guest speakers, Professor Bibas Chakraborty and Professor Umashankar Thayasivam, for accepting our invitation very enthusiastically despite their busy schedules. I must mention our deep sense of appreciation to all our speakers for gracing this occasion and enlightening us with your invaluable thoughts and knowledge. We really enjoyed your presentation, and thank you very much again for making this a memorable event. Moreover, I like to thank in advance to all the presenters and attendees who will be joining this digital platform for the technical session. Thank you, Mr. S. Edward, Registrar of University of Colombo, and Mrs. Tarushika Padiranage, SAR of the Faculty of Science, for your encouragement and support. We also thank Mrs. Jayasuriya, the Bursar of University of Colombo, and Mrs. S. Pereira, SAB of the Faculty of Science, for handling finance in the entire process of the conference. We highly appreciate the leadership, encouragement, and extensive support provided by all the members of the Board of Management of the Center for Data Science for making this event more successful. We would also like to acknowledge the advisory committee for their guidance and support throughout to make this event a success. We sincerely thank all the reviewers for their commitment in reviewing papers within the stipulated time and all those who contributed towards handling the reviewing process successfully. All this would have been impossible without good financial support. Therefore, we would like to take this opportunity to thank our sponsors, Creative Software, our strategic and knowledge partner, and Altria, our technical partner. I would like to express our sincere gratitude for your contribution towards the success of this event. We acknowledge Dr. Lakraj, Department of Statistics, and Mr. Rohan Fernando and his team at Equity Knowledge Partner for their contribution towards the works of the conference that will be held tomorrow. Moreover, all the members of the Stat Circle and Committee for organizing the mini hackathon program, which will be held tomorrow at 4:30 p.m. onwards as the part of this conference. I take this opportunity to congratulate all the hackathon teams who have been selected for the final round. My heartiest thanks goes to Ms. Kaushani and the ITU team for setting up the conference webpage. A special thank you to Ms. Seka Daluwatumulla for preparing this event and all those who provided technical assistance. We take this opportunity to express our gratitude to the founding director, Dr. Rasika Jayatilaka, and the head of the department back then, Dr. Dilhari Atigala, for taking all possible steps to initiate the Center for Data Science. Last but not least, I acknowledge the staff of the Department of Statistics. This event became a reality because of the constant commitment of dedicated and energetic, permanent, temporary and non-academic staff members of the Department of Statistics. I really appreciate their efforts to make this event a success during this pandemic situation through an online platform. I sincerely apologize if I fail to mention any person who contributed to the success of this event. Thank you very much all and stay safe.
Thank you, Mrs. Hasani Karunaratne, for delivering the vote of thanks. Before winding up the ceremony, I would like to remind the audience about a few details regarding the upcoming technical sessions for today. Those who want to go to the technical session 1 on predictive analytics can use the same Zoom link, and it will start at 11:15 a.m. There will be another session held in parallel to this, the technical session 2 on data visualization. You will be able to find the link for this session on the Zoom chat and in the guidelines that we sent. After the lunch break, we will have the technical session 3 on machine learning, parallel to the technical session 4 on deep learning and AI. Then after the tea break, we will have the technical session 5 on natural language processing, parallel to the technical session 6 on machine learning and predictive analytics. After these 6 sessions, we can wrap up the events for day 1 and 21. You can refer the guidelines we sent for more details. Ladies and gentlemen, so it is time to mark the end of the inaugural ceremony of the International Conference in Data Science 2021, organized by the Center for Data Science jointly with the Department of Statistics, University of Colombo. Hope you all enjoyed the session and gained a lot from the amazing speeches that we heard. See you all in the next sessions.